Good day. My name is Spanda. I'm going to be doing a presentation on residence time of a vessel. Okay, what's residence time? It is the average time a particle spends in a particular system or a vessel. So in terms of reactors, it is the time it takes to enter and exchange the volume of the reactor. So this vessel can be a reactor, or maybe sometimes a distillation column, or any vessel, so to speak. It might be a tank filled with water or a JoJo tank. So the formula to calculate the residence time, or sometimes it's called the retention time, is the volume of the reactor or volume of the vessel divided by the volumetric flow rate, which can be outflow or inflow at steady state. So by saying outflow or inflow, we mean the flow rate into the vessel. For example, if it's a distillation column, then what's the flow rate into the system? Or you can use the outflow if you have only one outflows. For example, the outlet of a distillation column. At steady state, we mean like the amount of the liquid in your vessel doesn't change with time, and you can actually control that using a sight glass to say we are maintaining our level at this point. So plus or minus, we are saying like the volume within that vessel is not changing with time. So RT is our retention time in hours. Then V is our volume of the vessel in cubic meters. Then Q is our volumetric flow rate. Let it be outflow, inflow in cubic meters per hour, sorry. So an example, we'll do a steam distillation or deodorization. So deodorization is the final stage of the refining process, which is a steam distillation at elevated temperature under vacuum pressure to remove free fatty acid or FFA. Also to remove volatile compounds like oxidative compounds, which are aldehydes and ketones, and other contaminants based on their vapor pressure and volatility. So what we are saying here, a deodorizer is actually a distillation column which happens under negative pressure or vacuum. And the main reason of deodorization, we want to remove the odors in the oil, which are mainly caused by these aldehydes and the ketones, and also to remove the free fatty acid. So the deodorization is three main concerns, which are stripping of volatile components such as free fatty acid and secondary oxidation products. And this secondary oxidation happens in the bleacher, and I'll do more videos on the bleacher, and also removal of flavor and thermal destruction of pigments. What do you mean by thermal destruction of pigments? You notice that after your deodorization, there's a significant color change. For example, you have a color of 4 red from the bleacher, and after the deo, you get it less than 0.1. So there's also thermal destruction of these color pigments. So the peroxide value of oil is brought down to the minimum value possible in this process. So ideally, you want to bring your peroxide value to 0, but usually it doesn't happen. For example, in a plant where I work at, we take it to 0.1, which is acceptable. The deodorization conducted at low temperature with a lengthened period, which is your residence time, or high temperature with a shorter period could yield oil with improved stability. So what do you mean? You can conduct this deodorization at a low temperature. For example, say at 230 with length and period of time of your rotation time, for example, say 2 hours. Or you can elevate your temperatures, then shorten your rotation time to say an hour. Still get acceptable results in terms of your free fatty acid and your peroxide value. So you find that temperature, vacuum pressure, time, and the amount, which is the flow rate, and flow rate of the stripping steam would affect the deodorization efficiency, including the loss of the minor components and the final quality of deodorized oils. So in your deodorization, which is steam distillation, you find that temperature is the main component. So from 230 to 260 is fine, depending on the type of oil which you're processing. Your vacuum is also very paramount, usually from 4 up to 10 millimeters of mercury using the manometer, which is your absolute pressure, is fine. Then time, the minimum is usually 1 hour, depending on the volume of your deodorizer vessel. Then the amount which you use to control level in your deo, you can use either the inlet flow rate or outlet flow rate, and also the flow rate of the stripping steam. And I'll do another video on how to calculate this flow rate of the stripping steam. So deodorization is normally carried out at a temperature of 200 to 240 under vacuum pressure by addition of stripping steam. And for you to use 200, usually you need to have a good vacuum. Otherwise, 235 to 260, you can get away with a poor vacuum system. Amount of stripping steam levels is normally between 5 to 15% using weight basis of the oil for batch deodorization, while it is 0.5 to 2% again using weight basis of the oil for continuous and semi-continuous deodorizers. So you need to be able to calculate how much steam you're putting, depending on the flow rate, inlet flow rate of your oil. Sufficient contact between oil and steam needs to be attained to make sure the removal of undesirable volatile components. So what do you mean sufficient contact? We are talking about that retention time or residence time. So as I said, I'll give you an example of a deodorizer vessel with capacity or volume of 2.5 cubic meters, right? And your inflow rate is 1 ton per hour. So we know that the density of oil at the deodorizer temperature is 900 kg per cubic meter, which is true for oils like soya and cotton or canola. So this density is determined at the temperature of the deodorizer, because our density is dependent on temperature, because as you elevate your temperatures, there's thermal expansion and also your density will change. So now converting that to volumetric flow rate by dividing by density, we get that the flow rate is 1,111 cubic meter per hour, right? So dividing the volume of the deodorizer by the inlet volumetric flow rate, we'll find that the residence time is 2.25 hours or 2 hours 15 minutes. So temperature affects deodorization time. How? The higher the temperature, it decreases the retention time and efficiency. The higher the temperature, increase the efficiency. And again, thank you for watching. And if you have any queries, concerns, or additions, that's my email address. You can contact me, tubasband@gmail.com. And remember to subscribe and click and like and comment to my video on the YouTube. And I'll see you next time on another video. Thank you so much for watching. Bye-bye.